here we go. This is going to be fun. So our equation is 4 sine theta, and I need a deep knowledge of the unit circle for this one, and we're going to do a lot in our head based on our knowledge of the unit circle. So 4 times sine of 0. Sine of 0 is 0. So we are going to start with a coordinate at 0, 0. Okay. I need 4 times sine of pi over 6. Sine of pi over 6 is 1/2, and that is going to give me 2. So 2 comma pi over 6 is another coordinate. All right, we need 4 times sine of pi over 3. Pi over 3 signed would give me square root of 3 over 2, which is going to give me 2 square root of 3. And as a decimal, I'm going to go ahead and do that now. 2 square root of 3 is 3.464. Yes! I actually did do that one in my head. I wasn't looking at my answer key, which is off to the side. Why am I flexing mathematically? I don't know. It's awkward. After a while, when you've been teaching math for a few years, you'll start remembering things like the square root of 3 to 3 decimal places and stuff like that. Just good to know. All right, sine of pi over 2 is 1, so this will be 4 times 1, which last time I checked, it just gave me 4. So 4 comma pi over 2. Whoops, 2. And then you write the wrong number. Like you can quote the square root of 3 to 3 decimal places, but you can't write the right number. Anyway, 4 times, all right, sine of 2 pi over 3, that would be square root of 3 over 2. Same thing we got for this one. These are going to be the same, by the way. And I'll go ahead and give you a hint. These are going to be the same. These are going to be the same. These are going to be the same. I will save you the trouble. We'll just go ahead and write them. So this is going to be 3.464. Just doing that in my head there. No one's impressed, sir. And then these two are going to be the same. So 4, and then, by the way, these are the same. This is quadrant 1, this is quadrant 2. And quadrant 1 and quadrant 2 for sine have the same signs, S-I-G-N-S. So 4, let's see, that would give me a half, so 2, like I said. So 2, and then 5 pi over 6. And then 4 times sine of pi, which would be 0, so 0. So this one is at 0 comma pi. All right, let's plot some points. This is going to be great. And the logical progression from this is going to be important. So let's move around here. And again, the reason we're doing this and not starting with it on our calculator is so later when you are looking at a graph and you're saying, where does it start, where does it stop, what corresponds to what, you'll have some frame of reference for how this thing was built logically and sequentially. All right, let's do it. What color should we use? Let's use a different color. I'm going to go red. This one's going to be big and bold. 0, 0. It's no surprise to anyone. Rectangular, polar, whatever. 2 pi over 6. 3.5-ish. 3.464 if you do it in your head. 3.5-ish. And then pi over 3. 4 pi over 2. That one's on an axis. 3.5-ish. And then 2 pi over 3, 2, 5 pi over 6, and then 0, radius of 0, and then we go around pi. Well, you can't go around, you're already there. Okay, if you want to connect them and do it wrong, you'd connect them and it would look like this. Or that'd be really wrong. It looks like a hexagon. It's not. It's not. I didn't want to put too many points in here and confuse this. And this might turn out to be an absolute disaster, but it's supposed to be, and it's not on the right side, but it is on the left side, a circle. This is the equation of a circle. Here we go. Let's do it. If you graphed it, and we are in polar mode, press mode if you're not, turn it to polar. Y equals, really is R equals in this case, sine of theta. Whoops, it is 4 sine theta. Whatever, let's stick with sine of theta. Standard window, zoom 6. See that? If you change it to 4, then you just increased the diameter of this, not the radius, to 4. Now, I know that doesn't look like a circle, but our graph on my calculator is wider than it is tall.